So another pretty popular related rates type problem is maybe you have a spherical balloon, or anything spherical really. Not sure if that's how you spell balloon, but anyway, I digress. We'll keep going. So let's say you have a spherical balloon here, and I'm blowing this balloon up, so I got volume coming in the balloon, and I'm blowing this balloon up at a rate of, I don't know, let's say 800 cubic millimeters per second. And that may or may not be a lot. I guess that is quite a bit. But either way, let's say I'm blowing this balloon up at that rate, and I want to know something about the rate at which the radius changes at a certain instant when the radius is 1. So when the radius is, well, let's say like 4 inches, let's change it to 4 inches. When the radius is 4 inches, how fast is the radius changing? So you need to recognize what all these parts are when you're reading a problem. So for instance, dV dt, that's how much volume is going in the balloon, or how much air is getting blown in the balloon. Then if r is 4 inches, how fast is r changing? This is dr dt. So you need to get good at recognizing what all the parts are. So just as in the other example, let's say I have a related rate problem. The first thing is to establish an equation that relates all of these variables, like volume and radius and sphere and 4/3 pi r cubed is the volume of a sphere, and that relates the volume and the radius, and that's all I need. If I differentiate this, I get dV dt. I'm differentiating each side with respect to t. You'll notice 4/3 pi is just a constant, so this is not a product rule over here. Pi is not a variable. So I only have one variable, so I just bring the 3 down. So 4/3 pi times 3 is 4 pi. Bring the 3 down, rewrite the r, take 1 off the power, times the derivative of the peanut with respect to t, which would be dr dt. And so in this case, I'm looking for dr dt, so I'm looking for this one. I know that dV dt is 800, so this should be 800, positive 800 because air is going in the balloon. If this problem said something about a balloon losing air, then dV dt would be negative 800. Similarly, dr dt is what I'm looking for, and my radius is increasing, so the rate that the radius is increasing should be a positive number at the end. And this would be 4 pi times the radius is 4 squared dr dt. So 800 equals 4 squared is 16, times 4 is 64. So 800 over 64 pi is how fast the radius is changing with respect to t. And this would be in millimeters per second. This is in cubic millimeters, so the radius would then be measured in millimeters. So this rate would be millimeters per second. And there's another related rates problem, and this one was pretty short. I'm going to do one more in the next video, and